I guess we could use the day-night cycle now here to sort of calculate which sprite to use. And I guess we can do that by, let's say, int offset x equals day-night cycle night count modulo sprite count, right? Or maybe let's call it sprite index. So if we take the night count and do a modulo division here with the total number of sprites there are, it should give us the correct sprite index, the index of the sprite to use. And by index I mean 0 would be this one, 1 would be this one, 2 would be this one, 3 would be the center one here, and so on and so forth. And so if night count is 0, and we divide that by 7, obviously the remainder is 0, which would give us this one here. If a night count is 1, and we do a modulo operation on that, it would give us 1, which would be this one here, and then 2, 3, and we have to treat this one here. We have to give this one a special treatment, I guess, because it's double the size. But other than that, we can now use the sprite index to calculate the coordinates of the sprite. So let's see. So I guess let's say if sprite index, hold on, this is 0, this is 1, this is 2, and this is 3. So if it is 3, that'll be a special case. Yeah, let's go ahead and say int sprite width equals sprite width, int sprite height equals sprite height, and now we can just say if sprite index equals 3, then we just say sprite width multiplied by 2. I guess we don't actually need the height here as a local variable, but whatever. And also, let's say if sprite index greater than 3. Oh no, actually, hold on. If sprite index greater than or equal to 3, we need to just pretend like the sprite index is actually one more. So I'm just going to increment it so that we move it, basically we move it from here to here so that it still works out. Okay, and what we can do then is say sprite height equals sprite height, sprite width equals sprite width, sprite x equals the start coordinates, rightmost sprite coords x minus sprite index multiplied by sprite width. Oh no, that doesn't work because we just manipulated the sprite width in case it is exactly 3. We can simply use the constant value here. So since if it's exactly 3, the index will actually be incremented by 1. Therefore, this should give us the correct value. And I guess sprite y is always the same. I don't actually need to manipulate that, but let's just set it here, and this should do. I think that's correct. Now let's actually, in the draw method, before we actually draw the sprite, we will update it. And then call its draw method, pass the sprite badge, and the position. There we go. And again, position obviously is inherited from the base class sky object. And yeah. I guess we can already say, here, only draw if it's nighttime. So if day-night cycle is night, then draw the sprite. Otherwise, obviously, the moon should not be drawn. And we can now actually do the same thing in the star class. Let us move this into its own file by right-clicking it, quick actions, move type to day-night-cycle.cs. There we go. And now it's in its own file. Okay. I think that's it for the moon. I think it doesn't do much. It's just there. And it looks differently every night. So that's it. Okay. Now, let's go into the Sky Manager class. And what can we do here? I guess we just sort of have to spawn the moon on the very right hand side of the screen. Then have it move until it left the screen. And then just respawn it and just do that over and over and over again. And I guess the Y position is always the same. Doesn't actually, there's no randomization going on there. So I guess the Y position would be like 25 or something. Let's say 25. Or maybe 20. Let's go down here. Private constant integer moon pos y equals 20. I guess that'll be fine. And now, obviously we need an instance of the moon class somewhere. So let's create a field for that. Private moon. And let's see. I guess we don't actually ever have to despawn it, I guess. We just have to kind of move it around. So in the constructor, we could directly create an instance. Oh yeah, we need to implement the day-night cycle interface. For now, we'll just pass null. The sprite sheet is the sprite sheet. T-Rex is the T-Rex. I mean, just actually there. And the position will be a new vector. X position will be the screen width. So TrexRunner game. There it is. Window width. And the Y position, we just defined that as a constant. Moon pos Y. There. And obviously, we shouldn't just pass null. That would just end up in a null reference exception. So we need to actually implement that day-night cycle interface. And I guess our Sky Manager itself will be responsible for that. So let's implement the interface here in that class. day-night cycle. And the compiler will obviously complain because it doesn't actually implement the interface. Let's do that now. Implement interface. It should have now here generated these two properties. And just for testing purposes, we will now implement it in a very, very simple way by simply always returning true for is night, even though it's not actually nighttime. And the night count, I guess, let's say for now, so we can test it, that it changes. Let's say maybe let's use the scoreboard. And let's see. Let's say modulo 70. Does that make sense? Not really. Maybe let's divide it. Current display score. I guess it racks up kind of rapidly, so maybe let's just divide it by 20. Yeah, that makes sense, I guess. So that way we would the night count would slowly increase, and we would have a reference, a point of reference here, in order to test if the sprite of the moon changes properly. Okay, but obviously later on we will need to have a more adequate implementation for both these properties, but for now, for testing purposes, this will do. Now let's see. In the update method, first of all, we never want to remove the moon from the entity manager. So here we could say if sky object is moon, or actually if it's not moon, like this. So if the sky object is not a moon, so if yeah, the type doesn't match, if the sky object is not of a type that can be derived from the moon class, then it can be removed, but otherwise, obviously, we shouldn't remove it because the moon will always be there. It will just be repositioned and never actually despawned. Let's see. Yeah, okay. And now in the update method, we need to move. Oh, actually, let's change this here. Let's say, let's remove this again here. I got a better idea. If sky object is moon, and we can actually assign that to a new variable here. Then do something. Otherwise, just remove that object. But if it is a moon, then it will be assigned to this variable here, and then we want to do something with that. And what we want to do is actually just move it all the way back to the right-hand side. So let's say moon position equals new vector. Then the x position is the screen width. And the y position, again, simply the moon plus y, which we defined as a constant there. So now if that sky object that has just left the screen is of type moon, we will just simply reposition it and put it all the way back to the right side of the screen. Otherwise, we're going to remove it. Okay, now, obviously the moon also has to move, but I think it already does that, but on its own, since it's an implementation of sky object. And the sky object class already handles that for us here. So yeah, I think it's done. So let's test that, I guess. So for now we will see stars and the moon, even though it's not actually nighttime, but okay, so something is not working. Yeah, sorry guys, for a second my audio just kind of glitched out again, and I recorded a couple of minutes of footage without any sound whatsoever. So yeah, bummer, but yeah. Really what was wrong here is, first of all, in our constructor of the sky manager, when we instantiate the moon, obviously we are still passing null here, which is incorrect. We need to pass this instance of the Sky Manager, which is an implementation of the day-night cycle. So that was wrong. And the other thing was that actually in our moon class here, this draw method is never called. And why is that? Simply because we never actually add the moon entity to the entity manager. So let's fix that. Let's go into the Sky Manager. And we could go here and add the entity here in the constructor. But I think that's kind of weird to manipulate the entity manager in the constructor of the Sky Manager. That's kind of, I would consider that unexpected behavior. So what we're going to do is I'm going to cut this line here and move it to the update method. And obviously we don't have a variable named sprite sheet here, but what we do have is a field with a sprite sheet, and the same goes for the T-Rex. And here what we can do is say if moon equals null, then do this. And actually, let me add some braces here, move this up, and then we can safely add this entity, this moon entity, to the entity manager, like this. So now in the first update cycle, the first time the update method is called, we'll just check if the moon field hasn't been initialized yet. And if so, we do create an instance of moon and then add it to the entity manager. And something else that I wanted to change here is the despawn threshold here. 200 is a bit too low, let's say 100. And I think that'll be fine. So let's have a quick look. There it is. And you can see that every 20 points, it does actually properly change its sprite. Obviously, that's not how it's going to work eventually. For now, for testing purposes, I think this looks great. And I'm actually going to move the moon sprite up a little bit. So let's maybe set moon pos y to, let's say 16. And try this again. Maybe it was okay, actually. Oops, there. Let me just check again. It looks kind of, yeah, I guess it's fine. I mean, who cares about if it's 16 pixels or 20 pixels or 22? Who cares? Set this to whatever value you think is appropriate. Okay, and I'm just going to make sure that this time the audio was actually recorded properly. All right, so now that this is taken care of, let's just have a brief look here at the start class. Yeah, and I guess we can already use this day-night cycle interface here in the star class as well, because obviously stars should only be rendered at nighttime. So let's go ahead here and say day-night cycle, and create a field private day-night cycle there. And then initialize that accordingly. Whoops. What is day? It's an enum. Specifies day of the week. Okay. Day, night cycle. There we go. And then in the draw method here, we'll say if day, night cycle is night, then draw the animation. Otherwise, just don't. Yep, that's taken care of. And I guess now we can implement the actual day-night cycle. Oh, what happened? Oh yeah, obviously, when we call the constructor now here in the Sky Manager, the constructor of the star class, we need to actually pass an instance of day-night cycle, which again will simply be this. And yeah, everything should now still look the same because we hard-coded the isNight property to always return true currently, so that's fine. So yeah, I guess we can actually implement the day-night cycle. Another thing that we still need to do is implement the high score. I mean, we already implemented the visual part, but it's not doing anything. Let's see. I guess, well, since we're already working on the Sky Manager, I guess it makes sense to now fully implement the day-night cycle and take care of the high score after that. Yeah, let's stick to the program. Now, I guess this is the most challenging, in quotes, most challenging part, but it's actually not that complicated. Let's see. At the very beginning of this video series, we actually analyzed the game a little bit, and we found out that it turns to nighttime every 700 points, and then turns back to daytime 250 points after that, approximately. I don't know the exact value, but somewhere around 250 points. So basically, every 700 points, we change from daytime to nighttime, then wait for another 250 points, and then change back to daytime. Simple as that. So let's put those values in constants. Let's say nighttime score, 700. Let's say nighttime duration score is 250. Okay. And now every time the score changes, every time we reach a score that is divisible by 700, we need to change the nighttime. And then 250 points later, we need to change back to daytime. Let's see. And also we need to have some sort of transition animation. Okay, so what I'm gonna do is I'm gonna go ahead and create a new private field here. Oops. Private, and it's going to be of type float. And let's call it normalized screen color, maybe. And I'm going to initialize it with the value 1. And you're going to see what this is for in just a moment. Let me just go ahead and let's see. So we need to check whenever the score changes from, well, basically whenever we reach a score divisible by 700. So let's see. Obviously we need to check that here in the update method. Let's see. Yeah, I guess what we could do here is, first of all, let's create a new field that stores the score. Let's call it previous score. And then in the update method, we're going to set that field here at the very end, using the display score property of the scoreboard. And then we can check whenever the score changes. So let's see, maybe up here, we could say if previous score divided by 700 is not equal to scoreboard display score divided by 700, then we need to change to nighttime. What's wrong here? Oh, whoops. Of course. Oh, and obviously we don't want to hard code that. That's what we defined the constants for. There. Yeah, let's see. Now, at this moment, we want to change to nighttime, so maybe let's just encapsulate that in a method. Change to nighttime, and then another one, or maybe let's call it transition to nighttime, and then another one named transition to daytime. And then we're going to call this method. Whoops, what am I doing? Transition to nighttime. Okay, but we also need to be able to transition back to daytime. So let's see. Maybe here, let's actually make that return a Boolean. And if it is already nighttime, we want to return false. Otherwise, we can return true. And obviously, we need to add some code here. But for now, we'll leave it like that. And here, if it's not nighttime, then obviously it's daytime. That means we can't transition to daytime. So we'll return false, then add some code here, and whoops, return true at the very end of it. Okay. Let's see. Maybe we should also define a constant for how long this transition should last. And I thought maybe 2 seconds would be an okay value to use here. Let's say transition duration, and 2 for 2 seconds. What else? Yeah, like I said, we need to also be able to transition back to daytime. So let's see here. We said that once it is nighttime, we need to transition back to daytime 250 points later. So let's see. Maybe let's go here and say if is night, and well, I guess we can just do the same thing here and just add the duration of the nighttime in score points to the nighttime score. Does that make sense? No, I guess not. Let's see. Oh, let's create a new field and call it nighttime start score, which will be used to memorize the the value of the score as it was when we transitioned to nighttime. And then here we could say, first of all, when we transition to nighttime, that's the first thing that we're going to do here in the logic. Let's say nighttime start score equals scoreboard display score. And then here in the update method, if it is nighttime and the current score minus the nighttime start score is greater than or equal to the nighttime duration score. Let's put this condition here in parentheses. I guess technically we don't need to, but I think it's easier to read that way. All right. Yeah. So at that point we need to change back to daytime. So let's say transition to daytime. And I guess that'll be fine. But now we need to actually take care of the, well, actual transition animation. So let's see. Maybe we could set a flag for that. Let's see. Yeah, let's just go ahead here and create a new field of type Boolean, and let's call it is transitioning to night. Initialize it to the value false, and then here in the transition to nighttime method, we're actually going to set that field to true. Now, as soon as we indicated that the transitioning should now take place, we need to update it somehow. And I guess we can take care of that here in the update method. Well, actually, I just want to do one more thing here. When we start the transition to nighttime, we need to set this, what's going on? I can't type today. Set the normalized screen color to 1. And 1 basically represents white. And 0 will represent black. So when we start transitioning to nighttime, obviously we're going to assume that it's daytime currently, so we set the normalized screen color to 1, and we're going to do the same thing here in the transition to daytime method, but obviously the other way around. So I'm going to set it to 0 here, and apparently we can't, or obviously we can't transition. We can't be transitioning to nighttime when we're actually started transitioning to daytime, so that kind of would cancel each other out. So let's go set this to false here. And yeah, that'll be that. And also here, I guess we could say if is night or is transitioning to night. So if we're already in the middle of transitioning to nighttime, we can't start the transition again. So we're just going to return false in that case. Now let's see. And I guess what I'm going to do is create a new method here, because I don't want the update method to do too much. So let's say private void update transition. And I'm going to call that method right here. Like I said, no typing skills today. I don't know what's wrong. There. Update transition, there we go. And now we can handle the logic for that in this method right here. And let's say if we're actually not currently in the middle of transitioning, we're going to just return and do nothing. Otherwise, I just realized we need something in order to be able to update the transition, and that is an instance of game time. There. And we can pass that here, since we do have an instance of game time available as an argument here. So there. And now what I'm going to do is set this normalized screen color, which, first of all, we need to check something here. Well, I guess let's change this here. Let's say if is, come on, is transition into night, then do some stuff. Otherwise, we're not going to do anything. And the reason I changed this here is because there's also going to be logic for transitioning to daytime. So I guess since we have to make this distinction anyway, we can get rid of this, I guess, this kind of guard condition. So, okay, if is transitioning to night, then handle that. And what we want to do is update this normalized screen color field. And what we're going to do is, let's see. I guess we need to, first of all, store the progress of the transition of the animation. Or do we? I guess we can kind of just use this field. Let me think about that. No, I guess we can use this field directly. By simply adding the number of seconds that have passed between frames. Obviously obviously we need to cast this to a float. And then we're going to divide this by the transition duration value. And I just realized, I guess this makes this cast redundant. Since oh no, it doesn't. Oh right, yeah, it doesn't, because basically we're using the division operator overload of the double struct. But never mind. You need to cast this to a float first, and then divide by the duration. If we didn't divide by the duration, we would always this value would always take exactly 1 second to reach the value 1. But if we divide it by the number of target seconds, basically, then yeah, it should take exactly 2 seconds for this value to go from 0 to 1. Let's make sure that it doesn't actually exceed the value 1. So if it's greater than 1, we're going to set it back to 1. And I guess the implementation of the daytime transition will be very, very similar to this. So let's go ahead and create a new field. Here, I'm just going to duplicate this one and rename it. Is transitioning to day. And then I'm going to go here in the transition to daytime method and also add a new transition here. If it's already a new condition, sorry. If it's already transitioning to daytime, then we can't start the transition, so return false. And we're going to set the is transition to day field to true. And in the transition to nighttime method, we're going to set this value to false. And I guess that's it. And now in the update transition method, you can say else if is transitioning to day. And I guess we can just sort of copy this and adjust it a little bit. Instead of adding this value here, we're going to subtract it. And here we're going to say if it is less than 0, going to set it back to 0. There. And I guess that's fine. And now we can actually here in the isNight property getter here, instead of just returning the hard-coded value true, we're going to say we will consider it nighttime whenever the normalized screen color is less than 0.5. Oh, what's wrong with my typing skills today? Okay. And that'll be fine, I guess. Oh, and obviously we need to also update the night count property. So maybe instead of implementing it like this, we're going to actually make this an auto property with a private setter. And yeah, the initial value will be 0, since that is the default value of an integer. And let's go here in the transition to nighttime method and actually increment this property like this. And I guess this is also the reason. They must have implemented it in a very similar way, I guess, in the original game, because this might actually be the reason why this moon sprite here is the first one that is used. Because if we transition to nighttime the very first time, we will actually increment the night count to 1, and that'll give us a sprite offset of 1, and thus we will end up with this sprite instead of this one. I guess if we didn't want that, we could just simply initialize the night count value to -1, but since the original does it like this as well, so I guess we're fine, and it actually really doesn't matter. Okay, so what else? I guess, I mean, obviously the transition doesn't really do anything yet. It just changes some values, but that doesn't actually affect what is rendered on the screen, except for the stars and the moon, because it obviously manipulates these two values. But it doesn't actually change the color of the screen and stuff like that for now. But I think it is in a state where it can be tested, because now I guess the stars and the moon will actually not be rendered until we've reached 700 points. And then they should disappear once we've reached 950 points. So I guess we can test that, but first of all, I want to do something here. Yeah, there's something that we sort of forgot. We need to actually set the draw order of the moon. I mean, it's not really that important, but let's do it. So the moon draw order, I don't know if the moon should be drawn behind the stars or in front of them. I guess technically the stars should be further away than the moon. So maybe let's set the star draw order to -3, and the moon draw order will then be -2. And we need to actually use this value now. So here, when we instantiate the moon, let's actually go ahead and say moon.drawOrder, whoops, equals moon draw order. Okay, let's test this. So theoretically, the stars and the moon shouldn't be rendered initially now. And as soon as we've reached 700 points, they should appear, which is going to take a while, so I'm probably going to cut this out. Okay, so we're slowly approaching 700 points, so let's see if everything works out. And apparently not. We must have forgotten something, because I don't see any stars. I don't know about you, but I didn't see any stars in the sky, so something must be wrong still. Let's see what's happening. So if previous score divided by nighttime score, let's say previous score is 600. We divide that by nighttime score, and this is an integer division, so that would give us 0, is unequal to the current display score divided by 700, which is also an integer division. Yeah, this should be okay. Then transition to nighttime. Now, if it's already nighttime or it is already transitioning to nighttime, then return false. That's fine. The nighttime score will then be set to the current display score. Is transitioning to night will be set to true. Is transitioning to day will be set to false. Normalized screen color is set to 1, should be fine as well. The night count is incremented. And here in the transition to daytime, if it's not nighttime or seems correct as well. Let's maybe put a breakpoint in the transition to nighttime method to see if it's actually ever called. There. And I'm going to play the game until we've reached 700 points, so I'm going to cut this out very likely. Theoretically, now the breakpoint should be triggered. Yes, there. So let's check the current field values here in Visual Studio. So nighttime score should currently be 0. Yes, it's currently 0. So now it should be 700 something, or exactly 700. And I guess for the next couple step over commands, we will hear the sound effect or fractions of it. So that's going to be annoying, but whatever. Is transitioning today is false. Normalized screen color is now 1. Night count should be 1 now as well. There we go. Return true. That's also fine. It doesn't jump into this if block here, so that's fine. Then we're going to update it. Update the transition. Let's step into that. Okay, so that's immediately set to... Oh, I did it the wrong way around. Oops. Obviously, if we want to transition to nighttime, we need to decrease this normalized screen color value. Why didn't you guys say anything? Make me look really stupid. Okay, so let's swap this around here. There. So now we should be good. And I should be able to remove the breakpoint now, and everything should be working fine. Let me test this again, and again, I guess I will be cutting out this footage in the editing. So give me just 1 sec. Okay, so while testing this, I really realized that it really bothers me that the collision boxes of the cacti are still too large. So let's go into the cactus group class here again. And the current inset is 3. Let's maybe change that to, I don't know, how large is the smallest cactus? That should be this one here. It is 17 pixels. So with an inset of 3. Should kind of look like this. I guess we could... I mean, we don't have to use the same logic for each cactus group size. So for the small one, we could say we decrease the size by just 3. And then for the large group, we decrease it even more, but let's not overcomplicate stuff. So maybe let's go with... I guess we could go with 5. Yeah, let's change the value to 5. There. Everything should still work. It should just be a little easier now to avoid the cactus, the cacti, the cactus group. So let's start up the game again. And again, I guess I will cut out this footage in the editing. So let's see if we fix the bug. There they are. Great. And now they should disappear at around 950 points. Yeah. And the reason they don't appear exactly at 700 points is because it takes some time for the transition to be updated. And so halfway through the transition, that is actually when they when they appear or disappear, which is fine because there will be some animation going on. So eventually it will look good. And they should reappear. There they are. Great. Yeah, it looks just fine, so perfect.